Hello, everyone. I hope you're enjoying your second day at this amazing summit. And I'm absolutely delighted to be here again today, particularly given the pleasure of the guest I have to introduce to you. Sasi Duggleby is the co-founder and CEO at Venus Aerospace. So you've just seen that brilliant clip from Venus, and it's going to be a very exciting discussion about hypersonics and the future of flight. So leading this company is this very talented and dynamic person. Before launching Venus, Sasi was launch systems engineering and mission management consultant at Virgin Orbit. And she has spent her career growing multiple high-tech startup businesses. Perhaps most impressive of all, she was recently created the, if I may say, Badass Women in Aerospace networking group. So this is going to be a great discussion. Sasi, welcome.
Yeah, thanks for having me.
Let's start. Can you just give us a little bit of a top line of Venus Aerospace and the hypersonic vehicle and what makes this company and this vehicle so different?
Yeah, sure. So Venus Aerospace, we are commercializing a brand new type of rocket engine called the rotating detonation rocket engine. And what it finally enables is 1-hour global missions. So we could actually take off, our ultimate goal is to take off from San Francisco with jet engines, get out over the ocean, turn on our rocket booster, and then become a glider at about 170,000 feet, traveling Mach 9. Glide across the world, come to the other side, land in Tokyo, and then be ready to come back. And so you could do San Francisco to Tokyo in 1 hour, or Houston, we live in Houston, Houston to London in 1 hour.
So nothing difficult then?
No big deal, not at all.
Okay, so as we're looking at some, like I say, not difficult stuff here, not rocket science, or actually it is. That's
science.
Right.
Yeah.
We were just talking a little bit, and you had this great example using a bottle, and I said, take the bottle on. So go on, Sasi, do that.
Yeah, so the rocket engine that we're using, if you're a standard rocket, we'll say that this is my rocket, typically a rocket's gonna be about 90% propellant, and then you have this tiny little payload at the top. And so the rotating detonation rocket engine is so efficient that you would only need to be about 65% propellant, so, here. So yes, we could use this rocket to send more things to space. But what we said is, what instead, if you use this extra mass to put jet engines, wings, landing gear, all the things that finally made a rocket plane or a space plane possible. So you can flip it this way, take off, get up over the water, and be a boost glide system, and then come down on the other side of the world. So it all comes down to the world's most efficient rocket engine, which is what we are currently working on.
And I can assure you that's the first time that I thought I actually do understand a little bit of this rocket science stuff. So I thought the other interesting thing, we were talking last night, we were both at the Pogue Award dinner, and I thought the other interesting thing about your company here is the culture and your attitude about what your priorities there. Tell us a little bit about the people behind Venus.
Yeah, so my husband and I actually started Venus. He is the PhD rocket scientist, and then I have an engineering undergrad and an MBA. We were both working at Virgin Orbit, so we were dropping rockets from the wing of 747s. And we actually were deployed to Japan in 2018. He's in the Navy Reserves, and that's where the idea for Venus came. And so after we got Virgin Orbit all the way to launch, we quit our jobs in the middle of COVID. And it was, there were times I thought maybe we're crazy. We've got 2 kids at home, we're in the middle of COVID, and so we've got this idea on Venus Aerospace, and we want to go chase it. So have raised about $60 million in venture capital so far, and have hired some of the very best, so from SpaceX, Blue Origin, NASA, and then we've got the rocket folks, and then we also have some plane folks that are experts in aircraft and that sort of thing. So really, we've got an incredible team. We're still small. We're 70 people. And with some contracts and groups, we probably are about at 100. But so we're still small, but we are building world-changing technology with an ultimate vision of connecting the world in 1 hour.
So to that aim, give us an idea of some of the key near-term goals and key milestones, biggest challenges for this project.
Yeah, so we're currently firing our rocket engine. One of the best things, we're at Spaceport Houston. It's the middle of the Houston City Center, and literally our rocket engine fires outside our hangar at Ellington Airport. And so we're scaling up to build a flight-ready engine, and we want to integrate that rocket engine onto a vehicle and get it flying ultra high speeds. So that's really our near-term focus. We're really kind of doing a stepwise process to start with kind of flight test as a service and hypersonic flight testing for the Department of Defense, and then move to hypersonic drones, and then ultimately that commercial vision. But that's one of the nice things. It's not spaceplane or bust. We're able to start with much smaller vehicles and really get flights happening, burn down risk, continue to prove out the technology as we scale towards this ultimate world-changing vision.
And what sort of timelines are you thinking of then? Are we, is it decades, or what are we talking about?
Yeah, so in terms of getting things to flight, we're talking in the near term. In terms of long scale vision, decade. We used to say no sooner than 2030, but there's just a lot. The biggest challenge is probably going to be regulatory. So we have been working with the FAA. I actually just came over, literally ran over. It was where we were going to be late because we were meeting with the FAA to start those discussions, because we don't want to show up in 10 years and say, hey, we've got a space plane, we're ready to go. But then they're like, what are you talking about? Where did this even come from? So we recognize, get those discussions happening now so that we can start buying down kind of the regulatory risk. I mean, one of the challenges is you can't fly supersonic over land in the United States. So we've got a supersonic drone that's almost ready to fly. Well, where do we go test it? If you want to buy a valve, you can buy it off the shelf. It's not like you can go buy range access, and just pull it right off the shelf. So definitely some challenges, but they're not unsurmountable. It's just really engineering challenges at this point.
One of the big news things for you recently is this participation of Airbus Ventures. Can you tell us about that and what the significance is?
Yeah, so in this recent round of funding that we've been raising, Airbus Ventures came in as an investor, which was just incredible. It was just incredible diligence that they did, and then to come in and say, yes, we believe in Venus. And they put out a great press release of why they decided to invest in Venus Aerospace. And ultimately, they use the language that this engine unlocks the hypersonic economy. It enables advanced aircrafts. It also enables, near space missions and in-space missions that previously weren't possible. And so for us, it was just a sign of assurance from some of the world-leading experts in aerospace that, we've got something here.
And on that commercial side, you said, this is, it sounds very exciting, San Francisco to Tokyo in an hour, and the world within an hour is really what you're, and I know you're talking about this step-by-step process, but can you just give us a little bit of a insight into your thinking in terms of sort of the size of aircraft, number of passengers, how that would fit into the global commercial air transport system, and how it fits with the sustainability goals that the commercial aviation side is so obsessed, rightly so.
Absolutely. So we're looking at the commercial the one you saw on the screen. The Stargazer is our commercial vehicle. It's about a 12-passenger vehicle, about 100 feet long. So it's not a large airplane. The nice thing is, because of the efficiency of the rocket engine, in order to go from San Francisco to Tokyo, we would use 50% less jet fuel than a similarly sized vehicle. So instantly a more sustainable solution. We also, we're kind of standing on the shoulders of giants in terms of the propellant decisions that are coming down, but because of the ability for a rocket engine to combust a bunch of different fuels in different ways at higher temperatures, we can use SAF. We can use other options as they get proven out to the industry. That's not we sometimes refer to them as miracles. That's not a miracle that we want to go solve. We're going to let someone else solve it, and then we'll be able to integrate it into our engine.
But how would it physically work for the, for the 12 passengers?
Yeah.
Give us a little bit of color for how that would work.
Let's say you come up to the airport, you load the plane just like you would a normal plane. You get in, you sit down, you buckle in, and then you're going to take off with jet engines. So it's a normal takeoff, get out over the ocean, because right now you can't make that sort of noise over land. And so then it would be a 10-minute boost. It's about 0.3 Gs. So similar when you take off in a plane, it's 10 minutes of 0.3 Gs. We've actually had, one of the joys of being in Houston is we've got NASA Johnson Space Center and all the human factors folks there. And so we've had them run our flight profile, and they said no big deal. So yeah, 10 minutes of that, and then you just become a glider. And so you don't have to be an astronaut, you don't have to be some SEAL Team 6 member to go on this. It should be available for normal human beings like you and I. Not to say we're normal, but.
You're definitely not normal, but in a very good way, if I may say so, in a very good way. You're obviously very enthused for this. What most excites you about this project?
I mean, how does the world change if you can get anywhere in an hour? I mean, I think there's things we haven't even thought of. I mean, some of the easy answers are, global organ transplant, getting medicine out quickly. But I think it's going to open up opportunities that, that we can't even begin to think of. And so just the exciting possibilities are endless.
Are you talking to any airlines yet?
We've had some early discussions. We're still, moving down those paths.
Sassy, it's been fantastic. We could talk for so much longer on this this subject. It's a fantastic project. I certainly wish you all the best, and thank you for joining us today.
Thank you.